Hi, today we are moving on to our section 2, confidence intervals for a population proportion. Our learning targets for this section will be check the conditions for calculating a confidence interval for a population proportion, calculate a confidence interval for a population proportion, construct and interpret a one-sample z-interval for a proportion, and to determine the sample size required to obtain a confidence interval for a population proportion with a specific margin of error. When we are working with confidence interval for a population proportion, we need to make sure 3 conditions are met before moving on to calculating our interval. In AP Statistics, we will assume that the data comes from a simple random sample from the population of interest. Other types of random sampling use more complex calculations than the ones learned in AP Statistics. So when a problem refers to a random sample and does not mention other types of samples, we can assume that the sample is a simple random sample. Now going back to the conditions, which we've already covered, our first condition is random. Now, the data should come from a well-designed random sample or randomized experiment. Our second condition is independent. Individual observations have to be independent. Now, when sampling without replacement, then we need to check the 10% condition, which the sample size has to be less than 10% of the population size, to use the formula for the standard deviation of statistic. The third condition is to find out if our distribution is normal. So we do need to make sure that we check the large count since we're talking about proportion. And the large count states that n times p hat has to be greater than 10, and n times 1 minus p hat has to also be greater than 10 to prove that it is an approximately normal distribution. Let's review on how to check the conditions for a population proportion. So in this problem, Mr. Berkeley's class wants to construct a confidence interval for P equaling the true proportion of red beads in his container, which includes 3,000 beads. The class randomly samples 251 beads, which had 107 red beads and 144 other beads. Check whether the conditions for constructing confidence interval for P are met. So we do need to state all 3 conditions and explain all 3 conditions if they are met. So the first condition is random. The class selected a random sample of 251 beads from the container. So that's perfect. Our second condition is to find out if it's independent. Since they are selecting without replacement, we need to do the 10% condition. 250 beads is less than 10% of the population, which is 3,000. Then the third condition is to see if it's approximately normal. Since this is talking about a proportion, we need to check large counts. And the large counts is the sample size times the p hat, which our p hat here would be 107 red beads out of a total of 251, which gives us 107, which is greater than or equal to 10. And then 251, our sample size, times 1 minus our p hat, which gives us 144, which is greater than or equal to 10. Since all 3 conditions are met, it's safe to construct a confidence interval. Now, how are we going to create a confidence interval of P? Remember, in the previous section, we talked about the point estimate plus or minus the margin of error. The margin of error tells us how close the estimate tends to be to the unknown parameter in a repeated random sampling. The way we calculate the margin of error is using 2 factors. The first factor is the critical value, which is the multiplier that makes the interval wide enough to have the stated capture rate. The critical value depends on the confidence level and the sampling distribution of the statistic. The greater the confidence requires a larger critical value. And then we multiply to the standard error of the statistic. This general formula for finding the confidence interval is included on the formula sheet. Now, the sample proportion of p hat is the statistics we use to estimate p. Since we do not know what the true proportion of p is, we replace it with the sample proportion p hat. This gives us the standard error of the sample proportion, which is the square root of the quantity of p hat times 1 minus p hat all over the sample size. Now, to calculate a confidence interval for a population, we use the following formula when the three conditions have been met. Using this formula, which is right here, Z star is the critical value for the standard normal curve with area of C between negative Z star and positive Z star. Now let's look at this problem and see how to create a confidence interval. According to a 2022 Pew Research Center report, 75% of U.S. adults have read a book in the previous 12 months. The estimate was based on a random sample of 1,502 U.S. adults. Note that the conditions for inference are met. So this is the information that they're giving us. And notice that they did tell us that the conditions for inference have been met. If they had not, we would have to check the three conditions: random, independent, and find out if it's a normal distribution. So to create a confidence interval, we start with our point estimate, which is the 75%. So we're going to change it to a decimal, so 0.7. Then we need to construct our margin of error, which is made up of two factors: critical value times the standard error. So to find our critical value, which is our Z star, we will use the TI-Nspire to find the Z that corresponds to the area of 99%. If we look at our normal distribution here, that tells us the area is 99% and it has tails of 0.05. Now, we can use our TI-Nspire to find out what that area would be. So we would use inverse norm, our area to be 0.005, the mean to be 0, and our standard deviation to be 1, which gives us our Z star to be 2.576. Or you can use the table A found in your formula sheet and then find the area of 0.005 and then highlight to see what the Z value would be, which it would be about 2.58. Now we need to calculate our standard error of p hat since we do not have the true population proportion. So we need to make sure that we understand that this 75% is our sample proportion, our statistic, and our sample size is 1,502. Now we'll use that information to calculate our standard error of p hat, which we have our formula and we substitute our value and we get the standard to be 0.011. Now we have our critical value, we have our standard error, and we do have our point estimate, so we can go ahead and start calculating the confidence interval. So our point estimate, which is our p hat here, is 0.75. Then our plus or minus, our critical value that we found for before was 2.576. And our standard error is 0.011. And we will do the math for that. We'll do the plus and the minus, and we get an interval between 0.722 and 0.778. Now, to create a confidence interval, we can use a four-step process whenever they ask us to construct and interpret the confidence interval. So the first step is our state. We have to state our parameters that you want to estimate and the confidence level. The next one is the plan. Identify the appropriate inference method, which is extremely important, and then check the three conditions. The do, once the conditions have been met, then you're going to do your calculations. And then the last one is conclude. Interpret your interval in the context of the problem. So from now on, we're going to be doing state, plan, do, conclude in all of our problems. The inference method we will use to estimate a population proportion P is called a one sample Z interval for a proportion. It is extremely important that you identify the inference method you are using. Let us use the four-step process to communicate all important information needed when asked to construct a confidence interval. So a recent poll of 738 randomly selected cell phone users found that 170 of the respondents admitted to walking into something or someone while talking on their cell phone. Construct a 95% confidence interval for the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. So the first thing I want to do is I want to highlight that they are talking about a proportion. That tells us what type of inference we're going to need to do in order to construct a 95% confidence interval. So the first step is to remember we need to follow the four-step process: state, plan, do, conclude. So the state portion is we need to write down all the information for our parameter and our confidence level. So notice our confidence level here is 95%, and our proportion here is P, which is equal to the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. This is the population proportion. And our P hat, which is our statistic, is 170 of the respondents out of 738 admitted to walking into something or someone while talking on their cell phone, which is 0.230. Now the next one is the plan. So we need to identify the appropriate inference method. So remember at the beginning we highlighted proportion, and we're talking about the confidence interval. And there's only one sample here. So our inference method that we're using in our plan section is one sample Z interval for a proportion. So now we need to check the three conditions. Is it random? So a random sample of 738 cell phone users. Then we need to check, is it independent? So if it's independent, we need to check the 10%. So we have to state that it's reasonable to assume that 738 is less than 10% of all cell phone users. And then we need to check the normal distribution. So because this is a proportion, we need to check large counts. And the large counts, remember, it's N times P hat because we don't have the true proportion. So we're using the statistic here. 738 times that 0.230, and we get 170. And then N times 1 minus P hat, which we get 568. And both are at least 10. So it satisfies all three conditions. The fourth step is the do. If the conditions are met, we're going to perform the calculations. So remember, we need to find the Z star. We can find it using our calculator. So we first need to know, this is the formula we need to use. We need to find our Z star and our standard error. So our P hat, since we don't have the true proportion, our P hat is 0.230. Our z interval, which remember we use inverse norm, if it's a 95%, the tails will be 0.025. So when we put this in our calculator, or you can use table A, we get 1.960 times the square root of p hat, 1 minus p hat, over our sample size, which is 738. We go ahead and do the calculations, and we add and subtract those values, and we get our interval to be 0.200 to 0.260. Now, you can use a calculator to verify your interval is correct, but I would not recommend to use it alone without showing work on the AP statistic. I will show you in class how to verify with the calculator. And then the last step is to conclude. We need to interpret our interval in context of the problem. Remember, our conclusion is about the population, which is users who would admit and not the sample, those who admitted. So our conclusion, we would write, we are 95% confident that the interval from 0.200 to 0.261 captures the proportion of all cell phone users who admit to walking into something or someone while talking on their cell phone. Now let's practice on interpreting confidence level that we did in the previous section. We're still talking about the cell phone users, so they do want us to interpret the 95 confidence level. Remember, we do need to talk about the population. So if we were to select many random samples of 738 cell phone users and construct a 95% confidence interval using each sample, about 95% of the intervals would capture the proportion of all cell phone users who would admit to walking into something or someone while talking on their cell phone. And just an exam tip, you can use the calculator, but on my exams, I do require you to show your work since it is an important part of the AP Statistics curriculum and the grading. In planning a study, we want to choose a sample size that allows us to estimate a population proportion within a given margin of error. We use the following inequality for size n, where z star is the standard normal critical value for the level of confidence we want. P hat is a guess value for the sample proportion if it's not given to us. And if it's not given to us, we're going to use p hat to be 0.05. So notice that this is what the margin of error actually equals. So if we're trying to find out the sample size, for this, we would use this inequality. Let's practice determining a sample size. So in this problem, it states, a company has received complaints about its customer service. The managers intend to hire a consultant to carry out a survey of customers. Before contacting the consultant, the company president wants some idea of the sample size that will be required. One value of interest is the proportion P of customers who are satisfied with the company's customer service. The company president wants to estimate to be within 3 percentage points at a 95% confidence level. How large a sample is needed? We will use the inequality that we stated above to find the sample needed. Notice here, we have no idea what the proportion of satisfied customers is, so we will use the p hat to equal 0.5 as our guess to be what our p hat would be. So we find our critical value, which is 1.96 for a 95% confidence interval. Remember, we find that using inverse norm. We have our p hat to be 0.5 since they did not tell us, and they tell us that they want it within 3%. So that's 0.03 is our margin of error. So they want it less than or equal to that, and I don't know what the sample size is, which is what we're asked to find here. So we're going to do our regular algebra to solve this inequality. We're going to multiply both sides by 1.96, and we're going to square both sides, multiply both sides by n, and then we're going to go ahead and divide. So we get n to be greater than or equal to 1067.11. So now we do need to interpret that information. So the sample that we need, the sample size, would include at least 1,068 customers. So we need to take that into account. And as we wrap it up, these are the important learning targets for this section.